Hello everyone. You know, I very rarely appear on camera. Well, the whole thing is that I don't think my face is so interesting for everyone to observe and behold. It's more interesting to watch all the action that I shoot. We shoot an hour installations, and I go on some business trips. There I shoot interesting specimens. I try all the time to show you something new, but all this I combine with the work that I do. And in the next video, for me it was very exciting work when I did the video shooting. Therefore, maybe those explanations, fragments, the fragmentary nature of this video, it will not give you a complete picture. But it was very touching, very anxious for me, very responsible. The whole thing is that we in a very short time frame, that is literally in September, started on the drawings, and now in mid-February they're in literally 4.2 months they assembled a whole flow installation, and in doing so applied the most innovative technologies for processing polyethylene. That is, at present most companies are only still in laboratory research on how to properly recycle polyethylene. And polyethylene, for understanding, we have 13 to 15% formed in waste. And it is not recyclable by anything today. That is, it is simply dumped, so to speak, in landfills. And, with a decomposition period, so to speak, there from 500 years one can understand that everything else will decompose and the landfill grows practically only on polyethylene and other plastics. Of course, someone will say, there are sand polymer mixtures. Accordingly, there are secondary granules and other, but ask yourself why all this one way or another ends up at landfills. It's just that somewhere there is no such high demand, somewhere the raw material is too thin, there are 17 microns, maybe it is simply washed away by water. Somewhere, there are 3-layer plastics that also do not fit, some impurities, paints, there is everything. And pyrolysis, as they say, can be said to be the only salvation from all this event. Moreover, with its help it turns out so cool, and a huge amount of pyrolysis, liquid. But one way or another it turns out that it is polyethylene cannot be fully processed by pyrolysis. That is, there are two main problems. First, during pyrolysis, it simply lines the drum reactor. We have indirect heating through the wall. That is, accordingly, and with this lining in education, then thermal conductivity sharply decreases and the reaction fades. Then, these deposits, they're coking or whatever you want to call them, they are directly, well, with a jackhammer, need to be knocked off. And those gas mixtures that come out of the reactor, they instantly paraffin the entire condensation line. And thus you there, candle wax, as they say, one, get. That is, someone tries to condense this paraffin while it is still more or less liquid. Then various rectification columns are proposed. Someone thinks that it is possible there, with screws, for example, to remove this lining. But on the screw blades themselves, just as a buildup forms and all this matter rises. That is, one way or another now, no matter how long you are on YouTube, let's say, so, running queries, you won't really find anything related to the production of pyrolysis liquid from polyethylene. That is, in this case, I don't even want to say the word fuel, despite the fact that it is combustible. The fact is, that it is a valuable raw material for various chemical productions, and, accordingly, there is demand for it. So, here's what we can get and how it is done. That is, we have a reactor. We released a special design to avoid this formation of deposits. Moreover, we handled this task 100%. That's one. Secondly, at the output, the vapor gas mixture passes through a catalytic column. That is, in the catalytic column there, special catalysts, converters. There are particle traps there, and so on, and so on. There are several layers of various, materials that have been developed by us for a long time, and we obtain high quality paralytic liquid. That is, for understanding here, this video, which will be further, this will be now, only the first video. I hope there, a certain series of videos we will make on this topic. And we apply different catalysts. This is the catalyst, let's say, one of the weakest in terms of its properties and quality. That is, but it turns out, nevertheless, already, such a primary useful liquid. That is, it is not a residue there from paraffins, nothing, but it is so liquid, but it already begins to solidify at -10. That is, in the next video I will try to show the cleanest pyrolysis liquid. That is, I hope it will be the color of gasoline, and even in severe frosts it will not freeze. With all this liquid is obtained immediately from the primary run on our installation. That is, there is no need to perform additional distillations, decompositions, or anything else. But this indicates that the technology in operation is very cheap and the catalyst's service life is quite long. It can be measured in years with periodic cleaning, for example, every 6 months. I can, of course, here exaggerate a little, but long-term laboratory tests indicate very low degradation, yes, of the catalyst, which indicates high economic, say, in economic potential of this production. Accordingly, and what can we get with you, right? That is, pyrolysis liquid from pure polyethylene turns out, well, pure, conditionally, yes, that is, fully sorted their bags, t-shirt, packaging. That is, it can turn out 608. They're 80 with extra percent, right? And if but coke is practically not there, then there is very little carbon residue. That is, the reactor there after several hours of operation it does not even contain carbon. That is, as we roughly assume that all sorts of waste additives that are in waste plastic, that is, there are cardboards, particles, there are all sorts of aluminum, there, Tetra Pak, all this stuff, well, it, of course, in turn reduces liquid level output, but increases the volume, accordingly, of dry carbon residue. So, probably, no longer worth keeping you waiting. Maybe, I missed something, but the main theses I said. That is, let's for the first time in our lives, probably many of us, I, in particular, myself for the first time in my life saw, with my own eyes the recycling of polyethylene with, obtaining quality pyrolysis products. And here is the next video just. This is the beginning of this era of plastic recycling. And we will do, as they say, and make the world cleaner, and increase the raw material base, yes, of our country, our planet. Therefore, as some, here we go. Winter 730 kilograms into this bunker of polyethylene housing. That's all. They came up with such a knife. Lift it higher. With this knife, it is cut. And therefore we are trying it for the first time, it seems. We are preparing to launch our first flow-through installation. So, now we are watching. We have turned on the smoke exhauster. There is a vacuum. There is air pressure on the burner. All right, we are preparing to start. The first burner is being launched. Let's do the next one. The second one is in the piece. A total of 5 liquid-fueled and 5 gas burners. They are visible. In our design, there is also a catalytic column, because without a catalyst it is impossible to recycle plastic. Therefore, to begin with, recycle. Therefore, to begin with, flue gases we partially into the jacket through it we drive. And here it is already visible in it, the temperature began to rise. Although we have, here sub-zero. So this is how it all looks. That is, this is the operator's room. This is the extruder control cabinet. That is, in the extruder the material is fed into this hopper. And further, accordingly, we have a dispenser that removes chlorine. That is, more precisely, it binds chlorine into calcium chloride. Thus, in our reactor, chlorine is already bound and the gas outlet also with bound chlorine. Let's continue. Here our reactor rotates. Here we placed the burners not very conveniently. Over there. That is, now we are going on liquid fuel burners. The room, unfortunately, is very limited in size. That's why. Here we have the reactor. It is planned that, on the foot it will be drunk. Here is also a gland seal. Now we are looking here at the chimney for even heating. Installed. Here several meters high. Catalytic column. There we have 3 tiers it turns out. That is, accordingly, here we have a drive gearbox. Here is a gland seal. Here is the soot unloading unit. This is the soot that we tested it. Yes. There is a heavy fraction catcher, and then the catalytic column went. So. That is, so far what I can show, as they say, what to see, so it looks. Room 15 by 16 m. Well, we took, so far our standard line, condensation. The only thing, they added an air blower for you. We will experiment with the pressure in the system. Also, we have a bunch of parameters, being read, including there are flow meters on the gas. In order to fully know, and the amount of their formation, expenses on gas burners. There are level meters for fuel, that is. Accordingly, they will also calculatively show us the material balance, what is the output of liquid. Depending on the temperature, we will understand the ratio of gas to fuel, how much gas is consumed for its own needs. Well, in general, the task is a complete material balance. So, yes, here we have about 15 minutes past. What's there? The burner, yes, is glowing red. I just need to reboot. Let's go. Here we have the temperatures that in the furnace have risen. Now the burner, we will restart. Our pressure in the reactor has risen to 5 kPa. Here it is heated. Everything. Accordingly, all indicators, understood. No fuel. We have not yet turned on the raw material supply. Pressure on the machine is set to 8 kPa. Well, that's how I am. I will, as we go, as they say, provide explanations. So, about 30 to 35 minutes have passed since the start of heating. That is, in the furnace already, we see such temperatures. All burners on the first stage are working. No more is needed, apparently, in terms of power. Pressure at the reactor outlet 5 kPa. Temperature, but here it's small, because that there is nothing particularly to come out of the reactor. Here in the jacket, the column is heated, reaches its thermal mode of the pump. Operating speed. Here are other temperatures. Here again pressure, temperature. Understood, the tanks are empty. Here the gas pump is in manual mode, it is turned off. Right here, in front of it is pressure. Next, we have a flow meter. It is also currently not showing. I don't know if we will manage to turn it on this time. No, set the pressure set point to 5 kilopascals. Here. How many percent is the valve open, right? Well, actually, these are the data we have now. We have pressure appeared in the reactor because the air is heated, expands. And here you can see the flow meter started working. Accordingly, this means that we, through its signal wire we can read the gas consumption in the future. Here is our old installation. Working. Here, of course, the guys don't like to maintain order. Soot fell directly, dragging the wire along the ground. Well, that's it, they drove it into the soot. Now, need to put it in the jar. The jar has already broken over the years, they didn't knock down a new one. So, we are warming up for now. Stop. The reactor is almost heated up. Now it is already somewhere around 360 to 370 degrees. The drum is heated. We prepared nitrogen cylinders to drive out all the air. Here they are standing. You can, of course, use a nitrogen generator, anything you want, but what comes first, comes first. And here we have a tube. Yes, along the tube we will supply nitrogen. Inside, we have an oxygen sensor. Accordingly, we will see at the output, the air content. And based on this, we will conclude that we can start supplying raw materials. That is, if in cyclic installations we always rely on the fact that first the water vapor evaporates and then, moreover, in the same lines, non-combustible gases initially form various nitrogenous compounds, carbon dioxide compounds. These are simply inert gases. But here our raw material enters the reactor at 300 degrees. Plus the reactor is heated. And God forbid the residual air, as they say, does its job. Actually, it's better in our business to overdo than to underdo. And that's why there are so many ethers, as it were, for many years. So, here we see our time. Yes, we are already quite heated up, you can see the temperatures. So, the drum itself is already 400 degrees plus. Now, we will supply nitrogen here in order to displace all the air from the entire system. Yes, outside. We will connect the oxygen sensor to the relief valve. And when we make sure that our oxygen content is minimal, we will start the extruder. It is now in heating mode. Well, the most interesting part is ahead. So, we are purging the reactor with nitrogen. Not such a fast process, but you can see this temperature when there is nothing inside. Accordingly, no gases are coming out. It does not increase. And here we see that it has already reached 70 degrees, which means nitrogen is advancing through the entire line, displacing the air. No nitrogen, no pressure. Completely dropped, right? Starting the extruder. First feed of raw materials. Started rotating. Think now. Well, since it's our first time, we set the temperature based on somewhere in the area of the reactor furnace. So, these are the temperatures. Accordingly, we raised the temperature here. Here it is for us after nitriding. In the column up to 307 degrees, so that the condensate doesn't fall down. Raised it. Well, let's see. We think that these parameters are more or less correct. We'll show some activity. Our extruder started rotating. Here. The feed arrived, hopper. Here we also have special additives. Are added. In an amount there, well, less than 1%. Well, and we expect that now we have rollies. Started. Here we have this temperature started to dip because the raw material is going inside. Already. This burner was connected even more strongly. And here everything is still hot. The pressure is slowly starting to come out. Here the temperature is rising. If you open the graph, this is visible to us as such a murina color. The pressure slowly went up at the end. And this red graph is the first temperature. It started to fall. It was higher than the others, now it's down. That is, the raw material started to take heat. So here we have, accordingly, the pressure. So here we have, accordingly, pressure. Everywhere in the system went. He is already in the reactor. Almost 8 kilopascals. And all this in a matter of minutes. At the same time, we still only heat 2 distant burners, simply because the temperature is so high, the feed rate is small, such a heat-intensive body, very difficult to cool in the moment. Therefore now, when it has heated up everything, it is not even necessary to heat much now. Warm. So, this is our first combustible gas. As I was informed, now we will go take a look. Wow, here, you see, what a little retort. Now here the blower should be. Here it is, gas from polyethylene. Air. And here is the carbon unloading for us, will be. So, we have 40 minutes from the start of the process. Time to adjust the gas burners. Now, we are trying to ignite it. The temperature drops significantly, that is, the heat is being absorbed by the raw material. Pressure in the reactor. Here at the output, 270 degrees, should be somewhere around 350 in the end. The column is only poorly heated. But the pressure here is 7 with here. That is, the column does not practically take pressure, which means it is, well, let's say, easily ventilated. We are afraid that there may be deposits here, but we cannot heat it properly. So far, we have already 25% gas release into the atmosphere, therefore she had the opportunity to light the gas burner because there is already a decent amount of gas being released. Here you can see its formation on the release. That is, there is constant growth. Here in the graph we can see this. Pink, this is the growth of the reaction rate of pyrolysis. That is, it gradually grows. First fuel. Checking. Good. Traditionally, we need to check how it burns. Oops. It's gorgeous here. Now we will see how the fuel burns. Here the flame is already powerful. We will try gas burners, cat, launch. So, we managed to adjust to launch one burner, but so far besides, 1 minute is hardly enough opportunity to start, because we have here on the flare, only 7% is dumped. This is too little. So what else is interesting here? Here we have from the reactor gas already comes out at more than 300 degrees. Accordingly, the fuel has slowly begun to drain. Our current productivity, of course, is low, because it's the first launch. So here to expect right now, a surge of commercial fuel is not worth it. We have already reached late evening. Here I am, I don't know how visible I am. The flare burner is working. We didn't manage to connect the blower, so it still smokes a bit. There you can see how powerful the flame is already coming out, how much excess gas. Now for the first time we will need to start soot unloading. This is this Angel massive apparatus this. So this is how the situation looks inside. There are additives. Give. Reactor like this moves. Cycle. We have about 550 degrees here. From the reactor, gas is already exit at 350 degrees. Here, accordingly. So we go like this. Moreover, there are even many burners. 2 are working. You can even extinguish 1 more, because a lot of gas is also coming out. Today, for the first time, it's enough, the cycle is approaching the end. That is, we stop the supply of material. We are now slowly cooling down, the temperature is decreasing. Now, I will open the graph. On the graph, you can see the pink one, yes, it started to slowly fall down. Well, actually, we are going as a stop. Well, actually, we're going as a stop.